Today's daily LeetCode problem of the day is create binary tree from descriptions, number 2196. For this problem, we are given a 2D integer array descriptions, where descriptions of I is equal to parent, child is left, and it indicates that parent is the parent of child in a binary tree with unique values. If is left is equal to 1, then child is the left child of the parent. If is left is equal to 0, then child is the right child of parent. Our goal is to construct a binary tree described by descriptions and return its root. So if we look at the example here, we have 20, that's our parent, 15 is our child, and it is to the left because our third value is equal to 1. So 20, parent, 15, child, it's on the left. Again, 20, 17, 0, so 17 is to the right of 20, boom. So for this problem, we are going to use a hash map and a hash set. The hash map is going to keep track of all of our nodes. That way we do not have to individually name and track all the nodes, but we have them all where we can access them. The hash set is going to keep track of all the children. That way when we come to the end of creating this tree, we can find the root of the tree. So what we're going to do, first we're going to assign our map and our set. So map is going to contain an integer and a tree node. Our integer is going to be whatever value parent is, and our tree node is going to be a tree node with the value of parent. We're going to call this map. It's going to be equal to a new hash map. Then we can set up our set, which is only going to contain integers, and that set is just going to keep track of what integers appear in child. We call it children. That's equal to a new hash set. Now we're going to iterate through descriptions. So to iterate through descriptions, what we're going to need to do is for int node, but it's going to be integer arrays of node for each node in descriptions. So what this is going to do, this integer is going to return three boxes. It's going to be 0, 1, 2. 0 is going to be the parent, 1 is going to be the child, 2 is going to be is left. So what we can do now is int parent is going to be equal to node of 0. Int child is going to be equal to node of 1. And boolean is left is going to be equal to node of 2 is equal to 1. This is a Boolean expression, so if it's equal to 1, it will be true. If it's not equal to 1, it will be false. Now we can assign our values to tree nodes. So we will have tree node parent node is equal to a new, it's going to be equal to map.get in case it is in our map already, or default parent. So it's either going to get the value of what is stored in the key parent, or it will default with a new map key value pair of parent and a new tree node with the value of parent in it. Then we can put this combination in our map, so parent node. So we're either going to get or default this value and put it into our map either way. Then what we could do is set up our child node, which is going to be equal to a map.get or default child, comma, new tree node of child. And then we can put that into our map. So child, comma, child node. So now we have our parent node and our child node in our map. All that's left is to assign our child node to our parent node. So if is left, what we're going to do is parent node dot left is going to be equal to child node. Otherwise, parent node dot right is equal to child node. Very simple. Then, because child node is a child node, that means it cannot be a root to our tree. We're simply going to add child to our children set. So children dot add child. So this is going to ensure that child cannot be marked as the root of our tree. This is going to assign the child node to the parent node, either to the left or to the right. This is going to put all of our nodes into a map so we can keep track of them without having to worry, as all the numerical values of them are stored in descriptions. And this will traverse throughout the entirety of descriptions itself. Then we simply need to find our root. So tree node root is initially going to be null. And for each integer key in our map.key set, if the key is not in children.contains key, so if the key value is not in children's, that means it has to be our root value. So root is, because it's not a child in any of the situations. So root is equal to map.get key, so it gets whatever node that is. And we could break because we found our root. Simply return root. And let's run this. Passes our test cases, and if we submit it, passes all solutions. So let's check this out in Python. So our Python solution is pretty much the same, but it is going to be more optimal because of the syntax of Python. So nodes is just going to be equal to brackets. Children is going to be equal to a set. So this, we made our hash map and our set already. For each parent, child, and is left, is that how they denote it in Python? I'm assuming that they just do it like that. Is left in descriptions if parent not in nodes. So if it's not in node, then nodes of parent is equal to a tree node parent. If child is not in nodes, then nodes of child are equal to tree node child. If is left, nodes. But is left is not a Boolean in this situation, so is left is equal to 1. Nodes of parent dot left is equal to nodes of child. Else, nodes of parent is equal to, dot right is equal to nodes of child. Pretty simple. Then we can simply add our child to our collection of children. That sounds weird. Then we need to find our root. Very simple, same thing as last time. We got this. Root is equal to none. For node in nodes, if node not in children, pause, why would you be in children? Root is equal to nodes of node. Break. We got this. Let's go. We got this, guys. Then we simply return our root. Spell it right. Let's see. Run this. Cool, passed our test cases. Submit this. Cool. We could have done better, but look at us. We're beating everybody on the memory front. We're beating everybody on the memory front. Let's see this. Wow, this is way shorter than what I wrote. It's okay. Oh, shit. I can't even read this. Yeah, you can actually. That's the same thing I put. Same thing I put, though. So we're chilling. We did good. Thanks for watching. Follow for more daily LeetCode solutions. Hope you have. We won. We win, guys. Thanks for watching. Don't forget to subscribe. Follow for more daily LeetCode solutions. Yep. Check out my Instagram and TikTok. This is fun. See you guys.